Hello, everyone. I want to thank you for coming here on a Saturday morning, first time. You got up early to come here, so really appreciate it. I guess you have read about the description about this talk, so that's why you are coming. If not, that is fine. We will cover everything in an easy way. Any sort of questions at the end, even if you are a beginner, you are not familiar with CI/CD stuff and cloud, all are welcome. So let us introduce ourselves. I'm a software engineer at Red Hat. I've been here already for 3 years. I come from Spain, and I work in Rel Identity Management department. I let my coworker introduce himself.
So myself, Kaleemullah Siddiqui. I've been working in Red for almost 14 years, completed 14 years this month. And just like David said, me both are working on a tool called IdM-CI, which is part of the IDM Ops team. And yes, so let's go on.
Yeah, we're both celebrating our anniversaries just today. I'm making 3 years, and he's making 14. Thank you very much.
I completed 14 yesterday.
Yeah. Anyway, what is my purpose with this presentation? So I think this open source project has a lot of potential, and it's under advertised. So I would like to give it some love. It would be great if we got some contributors from outside of the company of Red Hat, or even other teams. I want to compare it to similar solutions in the market because there are a lot of them. The most popular is Terraform. We'll see a comparison later. And also, there are people in the public that have used this tool through our CI. So I want to get them to know how it works on the inside, whether you have used it, whether you have not. So let's get to it, right? So this is the structure. We'll start with an introduction, a general overview. Then we will show you some use cases, both with integration with a couple of CIs and a standalone. And then to wrap up, we will talk about open source contributions. So what is this word? Weird word, right? mrack, what does that mean? You may think that it's a wordplay like a multi-cloud mrack, maybe, right? Multi-cloud rack. But in reality, mrack in Czech means cloud. So that's why sometimes I pronounce it mrack, but you can pronounce it mrack as well.
Yeah, but it's not mrack, it's mrack.
Yeah.
So that way you have to pronounce it.
Yeah. It's a Czech word in origin. So, I guess you are mostly familiar with cloud stuff and CI/CD, right? Could anyone say in the public, what do these three have in common? Anyone? You are correct. But I was thinking more about here, they all have in common, multi-cloud provisioning. All right, I know this is not Ansible specialty, but it can work like that as well. So mrack is very similar. It's basically a multi-cloud, multi-host provisioning tool, which is built for CI and testing. We have it available in multiple repositories, as you can see, Fedora, Python, Copper, and GitHub. And we support, right now, these providers. We have Cloud OpenStack, AWS, we have also Cloud Beaker, and we additionally support libraries such as Podman and Libvirt. We will see this more in detail in the use cases section, how all this works and this mix of several clouds and libraries. And you may be wondering, so why mrack? why did you start this project? Why didn't you use some existing solution in the market of all of them that they exist? So we have to go back to 2019. In Red Hat IDM team, we were developing a CI, but we were using a tool called Linchpin. Maybe you're familiar with it. It was used a lot back in the day, and we were facing a lot of limitations with it. So that's how I started. But before digging deeper into this, let me introduce to you the mastermind behind this project, the creator. He's Peter Bobornik. He's a former principal engineer, software engineer, and manager at Red Hat. He left not too long ago, in November last year. Sadly, he deserted open source and went to Microsoft, but we loved him anyway. So I want you to know him even more. So what better way to do that than with quotes, right? Let's see some quotes of him. This is the funniest one, I think. I created mrack over several evenings drinking wine. This has merit because he was a manager at the time, and he doesn't necessarily have to do individual contributions. So this is basically a hobby project. It started as a hobby project of him, and it ended up in production. Another one, I'm tired of listening to people complaining about OpenStack. So basically, back in the day, we had a lot of outages in our OpenStack instance. And we needed some sort of software that would be kind of resilient, would work around against these outages, because it was disrupting a lot of the workflow of quality engineers and testing overall. And the last one, I hate Linchpin. All right, he doesn't really hate Linchpin, but you all know Linus Torvalds, right? Creator of Linux. So it kind of gives up this vibe of I hate everything. All right, enough distractions. Let's get back to the topic. mrack, it's not only a provider. It's not only a multi-cloud provisioner. That is only one part of it. It has two great features, which in my opinion makes it unique. One of them is that it's suited for multi-host setups and hybrid cloud. And with this, I mean, you can define a complex multi-host setup in just one file and in an agnostic way. You don't have to worry about the cloud-specific stuff. You don't have to worry about how a VM is called in AWS. You just write the definition in a YAML file, and don't worry about the rest, because this tool will translate the cloud specifics for you. And yeah, as I said, it translates generic requirements across providers, and you define it in a very seamless way. So, the workflow. As you see, it's pretty basic. We have an input. We have the execution, which is made of 3 layers that we'll see in detail in the next slide. We have the transforming, which, as already told you, it translates requirements from agnostic to cloud specifics. We have the provisioning and the output generation. Then the last step would be the output files. Are you familiar with Ansible? So it generates an Ansible inventory file, which can be used by subsequent CI phases. So simplicity above all else. That's what we needed at the time. No over-engineered stuff. We don't want that. So let's see in depth each step. So we have 3 input files. We have 1 configuration file. This is not very important. This is just to specify some paths of the rest of the configuration files. Then we have, this one is very important, and the third one as well. The provisioning config file does the mapping between the, we talk about agnostic definition, right? So check out this mapping. Let's say we want a small VM, right? We are just going to define, I just want a client VM, right? We are defining it here. I want a client VM. Then mrack will translate it. That is AWS. It will provision a T2 micro. So with this provisioning config file, we are doing the mapping. And you can customize as per your needs. And then we have the metadata file. Don't be confused by the name, because it doesn't have anything to do with metadata and images or any other kind of files. We just call it like this. And this is the file where we define all the VM specifications. I just put here a very simple example. I'm provisioning 1 host, Fedora 36, with client group, which in the provisioning config file, we are defining it as a T2 micro in AWS. In this file, provisioning config, we will have all the mapping for all the clouds, for OpenStack, for Beaker, for AWS. Then I want to explain how the internals work. So it's basically divided into 3 layers. First layer is transformer. So again, it translates from agnostic YAML using the provisioning config file mapping to the cloud-specific requirements. We have the provider. It uses Python Cloud APIs. For example, for AWS, it would be Boto 3. And then we have the output generation. So right now, we are generating 3 kinds of files: Ansible inventory file, and PyTest multi-host file, and PyTest MH, which is kind of similar to this. And these files are used by the CI after the provisioning. So let's say you could have provisioning phase, and then you have a setup phase where you install all your packages with Ansible. So Ansible will use this generated file. We'll see more details. Kaleem will explain in the use cases section. All right. So again, in this diagram, I'm picturing the workflow of how it works from the input to the generation of the output. So here we have metadata files. In this case, we're defining a Windows machine and 2 Fedora machines. So we're defining 1 client, 1 master, and 1 AD machine. This definition goes through mrack execution. It gets transformed, translated, provisioned, and we end up with this inventory file. We'll check more details about the inventory file in a future slide. All right, in this slide, I want to show you, this is, we use it daily, how you can define complex setups in a very easy way. So usually in other provisioners for multi-host definitions, you need even to define multiple files. But here, only 1 file, and you can do all sorts of combinations. You can define flavors, you can define network configurations, you can define architectures, you can, any kind of architecture. You can say you want x86 or x64 or IdM. That's fine, and you can combine all of them. And if your testing use case is something like this, that is perfect for you. So you said you are familiar with Ansible, right? So we follow this philosophy of domains. So here we group the hosts by domains. We have the real machines and the Windows machines. So this will get formatted in the output file. So then when we have to SSH or we have to execute playbook files, everything will be right away prepared and set up for you. Now, going back, I was telling you that a group of engineers back in 2019 were facing limitations with a similar tool called Linchpin. Have any of you used Linchpin in the past? Yeah. So basically our two limitations, the first one was performance and speed. When we would use Linchpin with more than 5 machines in parallel, it wouldn't work well hardware-wise. Like, it would need so much power, it wasn't efficient. So, sometimes in IDM, we want to provision even, let's say, 50 machines right away at the same time. So we needed some sort of efficient asynchronous provision. So this is what mrack does. It can provision 50 machines in, obviously, if there is if the cloud has capacity, it can provision it in just 5 minutes. You have all the PMs up and running. And the other one is resilience. So I mentioned before that back in the day we had a lot of outages. So we kind of needed some sort of, let's say, retry strategy. So imagine that you have an OpenStack cloud of 100 machines capacity, and there are already 80 of them in use, and you want to provision 40 machines. What the typical provisioner will do is provision the first 20. Then it will check it can provision more, and then it will fail. So mrack works in kind of a smart way. It will provision the first 20 VMs. It will check that it cannot provision more. So it will free up the resources. It will wait like 20 minutes, and we'll try again. And you can also customize this retry strategy. You can disable, you can enable. We have, if I recall correctly, we have 2 or 3 retry strategies that you can customize in the provisioning config. Then we have other great features. I would say that mrack is multi-everything. It's multi-cloud, it's multi-arc, it's multi-host, and it's multi-flavor. And you can combine all of this as you please. So yeah, it's pretty flexible. And not only flexible from the user's perspective, also from the development perspective. It's modularized. So we'll talk about that at the end, but if you want to develop a new cloud provisioning module, you won't take very much time. So this is a very interesting slide. Here I want to compare mrack to Terraform and Linchpin. The goal of this is not to say mrack is better than the other or the other and better than mrack. I just want to show you what mrack excels at. So obviously all of them are multi-cloud. Also, all of them are multi-OS, multi-flavor, and multi-host. But mrack, as I showed you in the metadata file, allows you to define it in a very easy, seamlessly way. The very unique feature about mrack is its transformer capabilities, which Terraform doesn't support a Linchpin either natively. It is also performant. It generates output, which Terraform can do as well. It has a retry strategy implemented natively, which in Terraform you will be dependent on the provider. And it's flexible. So I included a note here. So this comparison, it's one that we did years ago. So it may not reflect current status of things. Just for reference. Anyway, I'll let Kaleem continue. Thank you.
Yeah, so on the last slide, though we haven't checked what is the current status, but I still feel that some of that are still true. Like whatever we providing as compared to Terraform or Linchpin, it still holds true. But we didn't get the time to verify all those stuff. So okay, let's talk about the use cases. You have seen the theory part of it, right? But how are you going to use it? That's the main question, right? This tool exists, how you can use in a different way. There are use cases, for example, first being how you can use a standalone way, right? Because before integrating, you need to understand the tool, and you will be playing and trying to do the sub-development part around it. So we'll be discussing that. Then the second one is about the integration and where it can be integrated. It can be integrated in your CIs, it can be integrated in your testing tools that you may use, that like you taking care of the CI part in it. So that can be used that way. Okay, let's have a look at the standalone use case. So standalone use case is about, yes, like I said, it's about the development of mrack. And because, why? Because once you use the mrack in a standalone way, it gives you output files, and you may use it, call it the way you want to integrate it. So you'll explore that part in this particular use case. The important part about how you're going to use the mrack, like David told you in earlier slides, there are some input files required, right? And what those files are going to do, and what should be the content of those files. So there are 3 input files that we require, and what could be the content of that, we will have a look at on the coming slides. So let's have a look one by one. So that one, the first file is the config file that you need to give to a mrack tool to provide the input information, the places of the output files where you want to store the outputs that the mrack will generate. And there are some wheres that you can use it, but I think it's not related. But we just mentioned it is having more than those input and output files. You can mention some of the variables that mrack tool will use. So input files, there are 2 files needed, but there are more. But we have mentioned it just at the very minimum level, so that you people can understand. The first is about the provisioning config. It contains, I think I have a detail on that in the next slide, but the input files are provisioning config and the metadata we need. What kind of output files it will generate? It will generate the Ansible inventory file that will be consumed by your CI or your testing tools. And though we have a use case of PyTest multi-host, we are using a plugin, and for that we need this information of system that we reserve in a particular format, and mrack will help you to do that. Okay. So since this file, the provisioning config file, is very long, so I have split it in 2 parts. So the first part is about the cloud information. I have just mentioned here only the OpenStack part, but like one of the slides David shown that there are different providers you can club in. So this file will be a longer one if you're going to support more use cases. But here for the simplicity purpose, I have kept the OpenStack. So you define all those things like what could be the images, flavors, networks, what could be the default things there, and the key pair credentials, and even if you're using multiple profiles in the credential file of the OpenStack, you can define what could be the default one here. And there are other sections also here for users and all the other default sections, which is common across all the providers. You can mention using the key pair value thing. Part two is again it is having in two parts. The first part is about one of the things that I mentioned, PyTest multi-host, that needs the output in a particular format. You can define the default format of that here, and that will be used during the output generation. Inventory layout, David has shown you the complete file where how it was generated. But this is the default section that is inside the provisioning config, and this is the particular layout it will be used in order to generate the Ansible inventory file. Yeah, this is the important one because without this, nothing is going to work. You need to provide the metadata. It's like input, what kind of systems you need, what could be the flavors, what could be the OS, what could be the other things. I have again like kept it minimum, but you can change a lot of things. You can mention provider here, you can mention architecture here. So a lot of things you can fill in here, and those all will be consumed by mrack along with the provisioning config, and a particular output file will be generated, which you can consume. So yes, standalone, in your standalone use case, you will be using the CLI part of mrack. So there are some options available in the CLI part of it. So that, like see, there are multiple commands, subcommands, up, retry, SSH outputs. They do different things. Up is about the provisioning the host. SSH is about to connect to the host to make sure that, okay, whatever you have provisioned, those are able to, actually you are able to SSH to those or not. Destroy is about once you are done with the things, you can go and destroy those reserved VMs. And output list can give you an like list of the VMs that are reserved, it's still not destroyed. So you can consume that way. Yes, the mrack up command will consume the provisioning config and the metadata, and it will go this way. This is a long output, but I trimmed some line in betweens to make it like just visible, like proper in a proper way. So see, here is creating the some output files, and which you can consume. So I'm going because I'm going fast because we have some short time, so we have to cover up all the things here. Okay, so now coming to output files, I will be skipping the PyTest multi-host one because that's not related much here. So Ansible inventory file, again, it's a long file, and that's why it's in two parts, in two slides. The first part is about here the default structure you might have seen in the provisioning config. So see, the only entry that gets updated is here about the host name that you have specified in your metadata. So that gets paid, reserved, and then updated into the default format, which is part of the provisioning config. And yes, about this particular host, there's a lot of information which you can consume from the Ansible inventory file and use it for different purposes in your integration perspective. There's a lot of information about that, from which provider, or to the IP, OS, and all those things, which you can use Ansible variables and do the needful. Now, coming to the another use case, which is about the integration. So this is about integrating in one of our internal CI which we use, which we call IdM-CI. So how we are consuming this, integrating this in our tool is using the Ansible playbook wrapper, and that is that particular playbook we are using. We are calling the mrack up command there and storing the results and consuming that. And the last integration aspect is about integrating with the TMT. you might have heard of TMT, right? So it's a tool which manages your tests and executes them and different providers, cloud providers, local, you can run local as well. So how mrack is integrated there? Because they needed a use case of doing the provisioning in Beaker environment. And since we had that support, so they have added it through a plugin. They have a lot of provisioning plugins, and it was integrated into the TMT as one of the provisioning plugins. So there is a link also, if you are interested how they have integrated it through a plugin, you will get an idea over there. Yes, now over
But
to
yeah.
David to talk about the contribution part, how you can contribute to the project.
Yeah, so just to quickly wrap up, we are all running over time. I encourage you, if you have some OpenStack, AWS, or Beaker instance, to try it out. You can go to the repository. It's called mrack. And you can try to provision something to let's see how it works for you. If you have any use case like a multi-host setups in your teams. Also, I wanted to say it's built to be extendable again. The code is modularized, so if any time in the future we wanted to add, let's say, an Azure provisioner, it won't take much time for you or for us. And yeah, any pull requests are welcome. Try it out. You can contact, we have email info in the repository. And yeah, that's it. I think we have only 2 minutes, right, for Q&A? 4 minutes, all right. I wanted to thank you for coming again and listening. If you have any questions, I will leave this slide so you can remember our names and connect if you want.
I think the quickest way to try this is using libvirt with mrack. You don't need anything apart from libvirt, right? That is the quickest way to do it. Try it.
Yeah. You can also use the Podman also.
Yes, that is true.
On the local, so
correct.
libvirt and the Podman are two options. You can use it without any cloud providers things.
Exactly.
Podman. It's also Podman. So you'll get containers running. Yes.
Yeah, but
you can use those.
Since Podman is not a cloud, what it would do is provision all the containers in the same. So it's for rather simple setups, because imagine you want to provision 50 containers and you don't want to set up an entire Kubernetes instance. So you can use mrack for that.
So there is a tool in upstream, IP Lab, which is like our upstream contribution. They are using this Podman feature there and deploying and testing the product there.
Mm-hmm.
In the Ansible inventory file, there was a mention of type IPA. Can you, I know, I mean, probably explaining it will be longer, but as quickly as possible, can you explain like what exactly does it, what do you mean by IPA and what is it trying to do?
That come to
type
type AD and type IPA, right?
Right.
So it's a part of the thing that is used in the PyTest multi-host plugin, where we specify and see, okay, this is something of type IPA and type AD. So based on that, there are a few additional things added into the PyTest multi-host output file, which is consumed by the PyTest multi-host. So there are a few things specific because our use case was to run with the multi-host, right? And even we started using PyTest, but there was no way of doing it through. So there was an upstream contribution for the multi-host plugin in PyTest, and we used that to modify to generate a particular file which is consumed by PyTest multi-host file.
Okay. Thanks.
So Kaleem, that type particular question, we have used IPA because we are using PyTest multi-host, right? So if we are using AWS or something else, it should be what? Like
No, that's about the cloud provider. It's about the it's about specific to the PyTest or multi-plugin.
Okay.
It's not about the provider you can use in the, can you go to the metadata?
Which one?
Metadata file. Any metadata file. Yeah, just keep the simple one. Metadata.
This
No,
one?
not this one. The next one, the metadata one. Yeah, here you can mention the provider.
Okay.
There are a lot of options. If you want to use the AWS, you have to just mention the provider, AWS provider, OpenStack provider, anything. So this can go and you can mention even the architecture.
Okay, just below the group,
Yeah.
I will specify
Yes.
a provider.
Probably you are not going to touch this type.
Okay.
That's why it was not described, because it will be internally used by the PyTest multi-host plugin.
Okay, thanks.
Kaushik, you asked about type. So we also use it for LDAP. So it is an easy identifier of what that is about.
Yeah.
So we had users trying to ask the same thing, and one request was, can we name it LDAP? So that is possible, just to easily identify what it is.
So any additional configuration to set up AWS provisioning, like he mentioned about Boto, so 3. So is there any, like I have a provision.config.yaml file. So what should be there in that for me to provision it in AWS?
You got the question?
Yeah.
So let's say I'm using mrack and I'm trying to provision 2 systems in AWS. So what should be the contents of the config.yaml?
So
So there was a section for OpenStack, there would be a section for AWS.
Okay.
Provisioning. And you can mention the credentials thing here.
Okay, the access
There's a
key
different
and-
format for that.
Okay.
And it will consume that and do the part of provisioning.
the idea is that you do all the mapping here and you abstract all the cloud stuff from the user. So the developer or the tester doesn't have to worry about that.
Okay, so each provider will have a separate section. Like here we have OpenStack. Instead of OpenStack, we'll have AWS.
Exactly.
Okay.
Yeah. So what client server for AWS would be T2 micro, it would map to a different thing in OpenStack, and you are able to customize that through provisioning config.
Okay, and the access key IDs will also be there in the config file, config YAML.
Sorry, which files?
Like to provision AWS instance, we need to have the access key
Huh.
IDs.
Yeah,
That should
yeah.
be part of the provision config, right? Okay.
This will be mentioned here in the AWS section.
For any more questions, please reach out offline to both of our amazing speakers today.
Thank you very much.
Thank you.
Thanks a lot.